My name is Ashish Kumar. I am an assistant professor, computer science engineering department, Ajay Kumar Garg, Engineering College, Ghaziabad. My subject is artificial intelligence and subject code is KCS 071. Today my topic is uniform search in AI. First, definition of uniform search. Uniform search is a class of general purpose search algorithm which operates in brute force way. Uninformed search algorithm do not have additional information about state or search space other than how to traverse the tree. So it is also called blind search. First I understand the uninformed search. That means some start state is given and some goal state is given. Okay, then how to reach goal state to start state? No any given idea. That means no any idea given to how to move on start to goal state. So I have to use here brute force techniques and blind search technique. That means brute force search technique, all possibilities movements are used for going from start state to goal state, and all states are follow. That means if goal state is here, then all possibilities move are used without no any idea here mentioned. So some types of uninformed search techniques. First is breadth first search techniques, depth first search techniques, bidirectional searching, depth limited search, uninformed cost search. First, breadth first search techniques. What is breadth first search techniques? Basically, in breadth first search technique is a most common searching techniques, and it is a most time are uses in searching techniques. This searching technique also are uses in the data structure. This is the basically breadth first searching techniques is a complete searching techniques, and it is a used of uninformed searching techniques. Is a best searching techniques algorithm. Basically here mentioned some point, so I read out breadth first search is the most common search strategy for traversing a tree or graph. Already say that these algorithms search breadth-wise in a tree or graph, so it is a called breadth first search techniques. Breadth means I have in the next slide I have to discuss what is the breadth first search. BFS algorithm starts searching from the root node of the tree and expand all successor node at the current level before moving to the node of next level. Again, the breadth first search algorithm is an example of an general graph searching algorithm. Breadth first search implementation using FIFO Q data structure. In breadth first search techniques, I have to use a Q data structure techniques. Q is the follow first in first out technique. I have taken one example here and discussed how to work a breadth first search techniques. Here a simple tree are given, S is the root node, then some child nodes are there. So here S is the my start node, start point, and K is the goal point. So then how to reach start point to goal point? No any information regarding states. So here that type of searching is a blind searching and brute force searching. So here already mentioned in previous slide, breadth first search techniques are uses Q. Q that means first in first out. Also Q follow in a Q, one is entry part and another is out part. That means one in front and other is rear part. Through rear parts I have to enter some nodes, and through front end I have to delete the node. Okay. So here I have to discuss. First I create one queue initially front and rear is 0, initial state. If enter a value first node is S in a queue, then front and rear is equal to 1. That means one node are entered in my queue. Okay. So I pop one node, that means S node, from outside the queue and traverse this node. So first I have to traverse S. If check S is my goal node. If S is my goal node, then searching is stop. But S is not my goal node, then I have to move another nodes and check the S node adjacent node, root adjacent node. So some nodes are adjacent, A and B. So A and B are put in a queue. A and B put in a queue. Okay. Again A and B put in a queue. Then first pop A and A is traverse. If A is again goal node, no. Then again searching are started and check the adjacent node of A. Then again adjacent node of A is A, C and D. Again next value is B. Again B is traverse. Then again check B is my goal node, no. Then again put adjacent node B, G and H. Again next node is my C. C is my goal node. Again C is my not a goal node. So this process time to time increases. I have to check level by level information. Level by level. Every level are calculated a goal node or not. If goal node found in this level is okay. Not, then move on another level, another level, another level. But here traversing is horizontal form. That means every node are cover. Every node are cover. That types of searching, it is called a complete searching. That type of searching is a complete searching, and BFS always provide a optimal solution. Any problem, optimal solution provided. Optimal solution, that means shortest cost of reaching from starting state to goal state. Okay, next. So final state are here mentioned. Some state are there using this problem. First A to S to A to B, and B to C, C to D, D to G, H, E, F, I, K. This is the total nodes are covered here. So in previous slide already mentioned breadth first search is breadth first search algorithm it is BFS algorithm start searching from root node tree and expand all successor node at the current level before nodes the next level. That means it is the traverse every nodes. It is traverse mostly every nodes and then searching is completed. Time complexity. The time complexity of BFS algorithm can be obtained by the number of nodes traversed in BFS until the lowest node. Lowest node, that means lowest is this node. All nodes are covered. This is a lowest node. Okay. So here where the D is equal to depth lowest solution and B is a node at every state. That means here also say that D is time complexity in this form B to the power D. That means B is my branch and D is a depth. Go for previous slides. In here number of branches is 2. Maximum number of branches is 2 and 3. That means it is a number of branches exceed, not limited. So that means here, and depth is 1, 2, 3 here mentioned. This is so here B is the branch edge and D is a depth. So time complexity is OB to the power D. Space complexity. A space complexity also mentioned here, O big O B to the power D. But in data structure form, BFS time complexity is big O V plus E. V is the vertex and E is the edge. But AI form, it is the big O B to the power D. Completeness. BFS is a complete, which means its shallowest goal node is at some finite depth, then BFS will find a solution. Already say that in previous slide, BFS is the complete searching. That means result is finally found using BFS. Optimality. BFS is the optimal if path cost is an non-decreasing function of the depth of the node. Optimal search already mentioned. Optimal search is shortest cost distance between start node to goal node. Another searching technique is depth first search. Here some point mentioned, depth first search. Depth first search is a recursive algorithm for traversing a tree or graph data structure. It is called the depth first search because it starts from the root node and follow each path to its greatest depth node before moving to the next path. DFS uses a stacked data structure for its implementation. The process of the DFS algorithm is similar to the BFS algorithm process. I have to take one example here. Here a tree is mentioned. Before this example, depth first search, it is a follow the stack. A stack is follow first in last out principle. First is come, then last is out. In a DFS major problem, it is a move deepest searching techniques. That means it is a move on one branch side, then it is a go for infinite length. That means infinite length, that means is move on. Okay, I have take one example here. So DFS is tree, S is the start node. Suppose S is a start node and G is my goal node. It is used stack techniques. Okay, DFS is used stack techniques. That means initially first node, start node is S, then it is put on stack. Put in stack. Okay, S is put in stack. Then traverse first S node. Okay, here traverse S node. Then adjacent node are put in a stack if S first node it is not a goal node. So adjacent node is here something adjacent node is A and H. So first put in A and next is H. Then I have to traverse next node. H is the my next node, H is the goal node. Then it is a close searching, but H is not my goal node. Then I have to move another node and check the adjacent node first. So here next next node is adjacent node H adjacent node is I and J. Then next I have to traverse, suppose J, next is traverse I, next of traverse K. When in wrong side searching is started. If wrong side, that means my searching is move on this side. Okay, then I have to backtrack, then I have to move here, then move here. So again backtrack and move in this. So that means my searching technique in different direction. So my goal node is founding is delay. If number of node is maximum. Suppose if number of node is infinite, so that of searching is goal node search is possibility is delay. That is incomplete searching techniques. Searching is possible, but it is a incomplete searching techniques because the time taken is more in case of infinite searching techniques. So if you use a wrong direction, so here some point is mentioned in the below search tree. We have shown the flow of depth for search techniques, and it will follow the order as root node, left, right node. That means already follow the some adjacent node is a root node, left and right nodes and conditions. And this is my searching techniques is a wrong direction. So I have to again move in this direction. So first I have to use, suppose enter here A and H. Then A is traverse first. Then I move in this direction, and this direction adjacent node, then this direction, then here backtracking as allow, and finally move on goal nodes. Okay, then you finally move on goal node. Next, here completeness. DFS search algorithm is complete within a finite state space, as it will expand every node within a limited search tree. That means here say that in case of finite, DFS is a good complete search technique, but in case of infinite and number of nodes are more, then completeness is low. Time complexity as it is BFS, it is also time complexity B to the power D. Time no many problem, B to the power B is a branch and D is a depth. Space complexity is the multiplication of both, and it is a DFS search algorithm is non-optimal as it may generate a large number of steps or a high cost reach to the goal node. It is not a optimal. Why it is not a optimal? Because this is my goal node. Okay, so shortest path, I think this is possible shortest path, but I have to cover this long distance. So it is not a optimal solution. I have to move next. Next is bidirectional search algorithm. Bidirectional search algorithms run two simultaneous searches, one from initial state called as forward search and other from goal node called as backward search to find the goal nodes. Bidirectional search replaces one single search graph with two small subgraphs in which one starts search from an initial vertex and other start the goal from the goal's vertex. The search stops when these two graphs intersect each other. Bidirectional search can use search techniques such as VFS, DFS and DLS. Some advantages also there here. Bidirectional search is fast. Why fast? Because both side directional are starting, matlab backward to forward and forward to backward. Then obviously the searching is fast. Bidirectional search required less memory. Definitely in a bidirectional search I would like to less memory. Next is some advantages also mentioned here. Implementation of the bidirectional search tree is difficult because it is managed the two tree and two path and two subtrees. Bidirectional search, one should know the goal state in advance. First, one should know the goal state. I take one example here. Here one example of bidirectional search. In bidirectional search, we have to check root node is 1, goal node is 16, but movement from root node to and intersect node is given. Intersection node is given. One is moved from, that means one is moved from 1, 4, 8 and move and 9, and 16 move from 12, 10 and 9. That means suppose I have to take one example. Two friends are there, different location and decided to meet in your house, another friend's or house. one friend, then after some discussion, he decided to have to meet a one location near about me and you. So here is there, suppose 1 is a friend and 16 is a friend. Initially decide I have to meet your home, that means your house, but friend decided why I have not moved on intersection points, why not I have to meet on intersection points. So distance traveling is decrease both. So one is moving on forward direction and one is moving on backward direction, and it is a intersection point. Then here mention some point. In the below search tree, bidirectional search algorithm is applied. This algorithm divides one graph tree into two subgraph. It starts traversing from node 1 in the forward direction and start from goal node 16 in the backward direction. The algorithm terminates at the node 9 where two searches meet. Okay. In BFS case, bidirectional is complete, but in DFS case, bidirectional is not complete. Why? In BFS searching techniques is in this form. Okay, that is cover every points, but in DFS it moves this way and it moves this way. So if it is move on different direction, then intersection point is not meet. So goal node is not find, but in BFS case it is intersect every points, so goal node is easily find out. Some here points. Completeness. Bidirectional search is a complete if we use a BFS in both searches. Previous I have to mention bidirectional search techniques is a BFS case is complete because in this figure, and DFS is incomplete because in this figure. Completeness. Bidirectional search is a complete if we use BFS in both searches. Time complexity of bidirectional search using BFS, big O B to the power D, space complexity is the same here, and it is a optimal search techniques. Next is depth limited search algorithm. Why use the depth limited search algorithms? Because previously I have to discuss about DFS, depth first search. Depth first search techniques are facing a one problem. What problem? It is the searching if one direction and number of node is infinite and number of node is maximum. So goal node if another different branches, so finding the goal node is difficult and complicated and time taken. So I have to use here depth limited search algorithms. In depth limited searching algorithms, I have to decide some levels. Because some levels, that means a level is defined initially कि your searching techniques is level 1 or level 2 and level 3. If in level 1 your search is completed, then okay. If level 2 your searching technique is completed, then okay. But in level and level 2 your searching is completed but your goal node does not find, that time it is the aborted. Aborted, that means searching is not completed. This is the main disadvantage of this techniques. Here some points are also mentioned. I have discussed a depth limited search algorithm is similar to depth search with a predetermined limit. Depth limited search can solve the drawback of the infinite path in the depth first search. In the algorithm, the node at the depth limit will treat as it has a no successor nodes further. And depth limited search can be terminated to condition failure. Already say that. First, a standard failure value indicates that problem does not have any solution. Cutoff failure value, it defines no solution for the problem within a given depth. That means no solution is found, that is a cutoff failure. and a standard failure problem no have any solution of the goal. Next, advantage are mentioned, some already discussed some advantage and disadvantage of the this condition, because it is a not a optimal searching techniques and limited search is memory efficient main advantage. So I take one example of here. Suppose here mention my searching is level 1, pre-decided my searching level is 1. If my searching level 1, that means after this level I have to consider all node are, this node are leaf node and all node are not visible. That means consider only A and B, last node. But my goal node is J. So my searching is, search here in here mention cutoff failure value. It defines no solution for problem within a given depth limit. So that is this type of problem arises. So my searching is incomplete. But if decided to level 2, then I'm searching technique is okay, completed. No any excuse for why you are not complete searching techniques, but it is basically solve the problem of DFS. In a DFS, a major problem, infinite values. So searching is incomplete. So this problem solving depth limited search. Here mention some point, completeness. DLS search algorithm is a complete if the solution is above the depth limit. Time complexity, DLS algorithm is O b to the power d is also time complexity, and multiplications is the space complexity. A depth limited search view as a special cases of DFS, and it is also not a optimal even if L greater than D. Next and last uniform search technique. Uniform, that means uninformed cost algorithm. Uninformed cost algorithm. That means cost means weight of every edge are given, and then where I have to move. So I take one example here. This is a tree and weight are every edge are given. I have to follow minimum weight side searching. So my searching is easy and minimum cost in a uninformed cost searching techniques. So it is covered here in figure. You have to check S to G. Minimum cost is 1 plus 2 plus 3. How to move? S to move two children A and B, and cost is 1 and 4. Then we are moved to from 1 because its cost is minimum. In A, C to D, A to C is 3 and A to D is 2. So I move A to D. Again D to F and D to G, cost is given 3. Then I have to move in this way and find the exact solution. And previously I have to discuss uniform cost search is a searching algorithm used for traversing weighted tree or a graph. That means searching technique is my weighted form. The algorithms comes into play when a different cost is available for each node edges. I have to already discuss in my example. The primary goal of the uniform cost search is to find the path to goal node which has the lowest cumulative cost. Uniform cost search expand nodes according to their cost from the root nodes. All are discussed in example. So it is a complete searching and optimal searcher. Optimal cost is find out through the uniform cost searching. This is a types of uninformed searching.